Hi, I'm Chris Walker. I'm an OpenVMS system manager at Newcorp. I've been working on OpenVMS since the late 70s, really, 70s and early 80s. I've been involved in OpenVMS continuously since then, not exclusively, but I have worked on systems and administered systems and managed systems. The contracts I've worked on include process control on alphas in the energy sector and many commercial systems on 780s, 750s, 730s, going back a long way. Recently, I've managed OpenVMS in the oil sector, which was process control. It also included development work. So I worked with Pro-C, Pro-Cobol, Pro-Fortran, because the routines that were running the process control were all bespoke and had been there for 20 or 30 years. I also administer VMS in the transport sector. And recently, I introduced monitoring to a number of organizations using the three examples that we're going to look at today. So I know some of the difficulties and pitfalls from experience. So if we just move on. The first commercial versions of OpenVMS, I think, came out in 1977, just in time for the boomer generation who were moving into the workplace. I was one of them. Many of the OpenVMS specialists I meet these days are from that era. And that means, of course, that they're hanging on near or well past retirement. Unlike Linux technologies, into which new blood does seem to flow, I think OpenVMS isn't attracting new blood, which is a pity because OpenVMS has everything to offer. Specialists are now retiring, and unfortunately the positions that they had are not being filled in sufficient numbers by new recruits. It's led to a dearth of OpenVMS resource, and many organizations still rely on OpenVMS on their critical systems, particularly in process control. Some cannot migrate. Others find it difficult to migrate. I'd say over the last 5 to 10 years, I've seen many organizations try to migrate and have a plan with a deadline. And quite often, the plan has run on for years past the deadline, and migration has taken forever. Even companies who have migrated don't always get what they expect. They find that what they've got now is not as reliable as the OpenVMS systems that they left. In my view, most migrations from OpenVMS seem to be more motivated by two issues. A lack of skills and a fear that there'll be no skills left to manage the systems. And number two, problems with integrating OpenVMS into modern infrastructure. This presentation hopefully will show we have developed a service whereby OpenVMS system support can be managed remotely by a centralized support organization. The service will allow companies to continue to rely on OpenVMS environments without having to worry about dwindling resources. Just to look at monitoring OpenVMS historically. Historically, there has always been built-in functionality. We use analyze/error. I think that was superseded by diagnose. We use SDA and a number of other commands that gather data about the current state of servers and clusters. In the past, I've used T4 and similar tools to gather basic performance information, but it still lacked integration with modern observability platforms. Checking the health of servers or server estates meant it means being proactive, doing daily, weekly, monthly system checks on every server. Today, this picture, it's changed somewhat thanks to VSI's VMSSPI-led product. OpenVMS can send alerts to a wide range of monitoring solutions, some of which we'll look at today. The ones we'll look at are the ones that I've actually implemented and have running. This opens the door to OpenVMS into enterprise monitoring stacks, so it can sit alongside Linux, Windows, and even cloud solutions. Before I get into the detail, if this stuff sounds interesting to you, then please get in touch. Feel free to reach out after this session. I would say, just a quick note before we continue, this isn't meant to be a sales presentation. We're simply sharing approaches we've used when monitoring OpenVMS environments. It's something we think could be useful to you or your business, and if it is, please feel free to reach out afterwards. Right, the VMSSPI-led product, it allows better integration with monitoring applications. VMSSPI, it allows events and alerts to be routed to modern technologies, including RabbitMQ, Splunk, Dynatrace, Slack, Datadog, PagerDuty, and even MQTT brokers. SPI has a 90-day license-free period, after which you are required to buy a license. There's a really good installation and user guide for VMSSPI. If this interests you, I advise you to download a copy. If you enter VMSSPI into a browser, the first link that will appear will be VMSSPI-VMS products, which takes you to the VSI product page for SPI. And on there, you can download the user guide, and there's also some other useful downloads, all related to SPI. The chances are that the second link that you'll get on the browser will be VMSSPI for VSI OpenVMS. And that link is a direct link to the user guide that I mentioned. VMSSPI does require OpenVMS to be using TCP/IP services, and it doesn't work with TCP-ware, for those who are still using it. VMSSPI is controlled by two files: configuration.dat, which largely controls the events that are routed. And possibly you know that VMS does generate quite a lot of events. If you install this, my advice would be to limit the events that will be routed down to a small subset. And then over time, grow your configuration such that you're allowing the events that you want to monitor to be routed. If too many events come through, it can affect performance on the VMS server, and it up to the point that it can even hang the server. The other file is messages.txt, and this file controls which monitoring technologies are enabled. Only 2 monitoring technologies can be enabled at any one time. I think this is due to performance concerns. For the record, other functionality that's been added is an MQTT broker, which enables OpenVMS systems to better integrate with modern systems. But that's not for today's presentation. We're going to look at the 3 monitoring technologies that we're going to cover. So the VMSSPI acts as an interface between OpenVMS and external monitoring systems. Once it's installed and licensed, it runs as a set of processes in OpenVMS, and it generates alerts and forwards them to chosen endpoints. Configuration of the endpoints is handled through messages.txt, which routes the alerts through to the relevant monitoring platform. We'll look briefly at 3. We're summarizing them here. For larger states, the RabbitMQ, Prometheus, Grafana stack is a good choice. It's best used in larger states where aggregated monitoring is usually the norm. Then there's Splunk, which is a good choice for monitoring a few servers, giving good per object coverage. And last but not least, there's Dynatrace, which is another possibility if your organization is already using it to monitor other systems. And Dynatrace is used a lot for monitoring these days. I've come across, I'd say 2 or 3 of my organizations use Dynatrace.
Chris,
yeah.
Just a quick question. Have you tried out any other architectures or product stacks using SPI?
So far, I haven't, Chris, no.
Okay.
The aim of all this is to move to a reactive model where the monitoring system alerts the service desk when there's a problem. And then the service desk can schedule diagnostic engineers to have some sort of plan for resolution of any issues. We're now going to look at each one of these solutions in a bit more detail. So the first stack is RabbitMQ to Prometheus to Grafana, where RabbitMQ is a message broker. Prometheus collects the metrics and Grafana visualizes them. So events from VMSSPI are routed into queues in RabbitMQ. Prometheus scrapes RabbitMQ's queue endpoints for queue statistics, and Grafana dashboards then display alert counts and trends. On the face of it, this technology looks complicated. It can be simplified somewhat by running these 3 in Docker. Depending where Docker's running, that could cause some performance issues if they're running on the same server, but Docker can be clustered. It's called a Docker swarm mode. And using that, you can get better performance. But obviously, there's additional configuration. And it does give, obviously, high availability. These products have existing configurations that allow them to work together. Usually, the configurations require some tweaking. For instance, IP addresses would have to be tailored to your environment, ports, etc. So an understanding of YAML configuration files is an advantage because all these three products and Docker use YAML configuration files. Prometheus is very good at monitoring aggregated events, but less good at monitoring per object events. Really, per object events in Prometheus tend to kill the performance. It works hard if you're doing per object, so we try to avoid that and aggregate things. So what this often means is that the help desk knows there's a critical issue, but it cannot pin it down to a specific server cluster.
Chris, just another question on that. Is there a known limit of monitoring objects, or is it a case of trial and error to find out what it is on your system?
I mean, there are so many factors that can affect that. The power of the server, the memory that you've got there, the number of cores. There's
nothing within the software that says you do 200 objects and that's it, you're done.
No.
Okay.
So it would be trial and error with the hardware that you've got. But again, this can all be scaled. Which further complicates the technology stack, but it can be scaled. It can be clustered in certain ways. Yeah. Right. To mitigate somewhat Prometheus's aggregation, RabbitMQ can be set up to give separation to events before they reach Prometheus by routing them to different queues. Prometheus then monitors the queues, and the data is passed to Grafana to display in dashboards, which the service desk can monitor. There are existing dashboards which can be utilized in Grafana, or you can develop your own dashboard. Obviously, an understanding of Grafana is an advantage. This approach, it scales well for large estates, offering aggregated statistics while avoiding performance hits from per object queries. So that really is where this sits. We will look at it a little bit deeper on the next slide. RabbitMQ can be configured based on severity or host name. That's because VMSSPI provides a routing key, and the routing key, as shown on the slide, includes the host name and the severity. Okay, so those two fields allow us to be able to set up RabbitMQ to route on severity, or we could even route on host. Now, RabbitMQ can support hundreds of queues. I think it might get, from a management point of view, quite difficult, but it will support lots and lots of queues. the main thing with queues in RabbitMQ is the memory. They take up memory. So the more queues you've got, the more messages they've got on the queues, the more memory that's taken up. And eventually, as the messages build up, they are swapped out to disk. So once messages have been swapped to disk, that can, to some extent, affect performance. RabbitMQ can be clustered. You can connect multiple nodes and effectively make one logical broker, which provides higher availability and obviously increases throughput. Another option is RabbitMQ provides an API for developers for most major development languages. C#, JavaScript, etc. You can develop an app that queries RabbitMQ directly, allowing you to see individual events that the full monitoring technology stack alerted the service desk to. I actually developed a working app in C# in approximately 1 day. Wasn't anything special, but I could look at the individual events if I needed to.
Chris, if you develop an app, would you still use Grafana to display the information, or
yes,
something else?
Yes, because I think the idea of having the app in this particular instance was to allow me to drill down when the service desk knew there was an issue, but they didn't really know what the issue was. So it allowed me to drill down into the event and look at the issue in more detail. And I wasn't really developing a replacement for Grafana. What I was trying to do was develop a way of seeing a per object event rather than an aggregated event. Yeah, the problem with an aggregated event is that a lot of the data is aggregated, so you don't see the item, maybe you don't see the host name, for instance. So with this app, I could get the event, I could get the host name, so I knew where the issue was. I could then direct engineers to look at that server and work on the issues that were arising, if that makes sense.
Yeah, thanks, it does. Yeah.
Right, well, the second option is using Splunk. And Splunk does provide powerful searching and visualization capabilities. Integrating to Splunk, it's a lot easier from a technology stack point of view. It requires some configuration within Splunk, but once done, you can view per object events and they can be graphed onto an internal Splunk dashboard. Configuration, it's quite straightforward once you understand the eccentricities of Splunk. A Splunk administrator creates a token. It's called a HTTP event collector, so a HEC token. And VMSSPI is configured to send alerts using that token. Events appear in Splunk's search interface, where dashboards can be built reasonably easily, really. I built one in a couple of hours to monitor the events. One downside of Splunk is that there is a free version, but it's for personal use only. In commercial environments, Splunk requires a license. Splunk's flexibility makes it ideal for ad hoc analysis and reporting. Splunk also can be clustered. There's a version of Splunk called Splunk Enterprise, and that can be clustered, so you can get scalability and HA. Last but not least, we have Dynatrace. Now, Dynatrace is used a lot, and it does offer quite deep observability, and it has a built-in AI insights engine. Integration with Dynatrace on the face of it looks simple, but in reality, there's quite a lot of configuration within Dynatrace to monitor OpenVMS events. Dynatrace is great for mainstream things. It has built-in support for quite a lot of different products, but not OpenVMS. And the only current easy way is to use the built-in, it's got a built-in open REST API, which is an open standard. A Dynatrace administrator needs to provide a token, very similar to Splunk, which has a necessary scope to allow monitoring of the events. VMSSPI, again, is configured with that token to send alerts. Filtering the events for specific environments and event types can be quite complex. This is where I spent most of my time. Since monitoring OpenVMS is mainstream in Dynatrace, I would only recommend Dynatrace if the organization's already using it to monitor other systems. But with some effort, you can produce dashboards and problem pages where issues are highlighted. And we've got this working in one big organization, and it works reasonably well. Again, Dynatrace can be clustered. I think the product's Dynatrace managed. Okay. Right, to summarize, it'd be good to determine which tools your organization already uses. Yeah. But for small open VMS estates, per object monitoring preserves data fidelity, as we mentioned earlier. But for larger estates, aggregated statistics, they reduce payload and improve performance, but you lose some of the data. So it's a balancing act, really.
So, Chris, is there a breakpoint between RabbitMQ stack and Splunk, or
Splunk? Yeah, Splunk. Splunk when it starts to have issues, you can improve it by tweaking the configuration, but the following problems can occur. And if any of these operations take more than 30 seconds, then you've got performance issues. So response times from endpoints. There's a thing called the forwarder management homepage. If that takes more than 30 seconds to load, you've got problems. If you go searching for a host name or app running to completion, and you would be doing that in the case of OpenVMS, you'd be looking for a host name. If that takes more than 30 seconds, then you're probably getting to the limit of what it can support. Listing matched agents as well for server classes to load. If all of those things, if any of those take more than 30 seconds, then the performance needs looking at. And that might be the time where you tip over to the RabbitMQ stack. Or you could look at clustering or lifting the scale. The problem with clustering, of course, with Splunk and Dynatrace is that there's more cost involved, because they always recommend that you should cluster a minimum of 3 servers and not 2, so your licensing costs go up quite a lot. Is that okay?
Yeah, thanks, that's fine.
Right, so Newcorp, it fits into this operational picture because Newcorp has already got the infrastructure and the expertise to monitor OpenVMS servers in place. It's already in place. What it offers is, with the monitoring in place, when alerts are generated by the OpenVMS environment, it flows into our service desk. The service desk acts as the first point of triage. We can review alerts, we can identify potential issues, we can determine whether further investigation is required. We have a team of technicians who have years of experience on these systems. If an alert indicates a genuine problem, it's escalated to our diagnostic engineers. The engineers specialize in OpenVMS environments and are able to analyze systems behavior. We can investigate logs, we can identify the underlying cause, and where necessary, we can implement fixes or recommend corrective action, or work with the customer's internal teams to resolve any issues. The aim's simple: ensure that OpenVMS systems remain stable, monitored, and properly supported, without organizations needing to maintain the level of specialist expertise internally. We're also training younger engineers so that coverage continues when us old farts retire or drop dead. Our team is happy to talk to you on any OpenVMS or monitoring query you may have. So you can schedule, diagnose, and rectify any issues. So monitoring OpenVMS servers no longer means relying on legacy tools. With SPI, administrators can connect OpenVMS to modern monitoring solutions. They can gain real-time visibility. And obviously, proactive alerting and integration with the monitoring strategies means that we maybe don't need to be doing so many daily checks, weekly checks, monthly checks, because if these things can be monitored via monitoring system, any alerts can come from that. Where you're managing a handful of servers, modern monitoring ensures OpenVMS continues to deliver reliability in today's hybrid IT environments. So it should remove a lot of the work that you have to do on a day-to-day basis, and makes it a lot more reactive to issues that the monitoring system is seeing. Well, that's the end, and thanks for listening if you are still listening, and we're happy to take any questions that you've got.